Okay, so this video is going to be on scientific notation. It's something important that we need to cover in any science class that's dealing with numbers. Now, scientific notation refers to expressing a number as a product of any number between 1 and 10 to the 10th power. Scientific notation is mostly used when dealing with large quantities of numbers containing many digits, since it shortens the notation. So sometimes we might be dealing with numbers, and if I just had an example, just some really long number. Maybe I don't want to write that number out, all the time. I can shorten it and put it in scientific notation, and it will be the same number. It will just be expressed to a certain power. So if we look at how to do this, if we have a number like our original number here, our first example, 76,300. If you notice, that's in regular notation. In scientific notation, it would be 7.63 times 10 to the fourth. So to put a number in scientific notation, we would need to find the decimal and then move it either to the left or to the right until we come to a number between 1 and 10. All right, so if this number is 76,300, since it doesn't have a decimal, I'm going to, the decimal would be at the end. So to put that in scientific notation, I would move my decimal. I'd have to move it to the left until I come to a number between 1 and 10. If I move it 1, I have 77,630. That's not between 1 and 10. Move it again, I have 763.0. Move it again, I have 76.3. If I move it one more time, put my decimal, I got 7.6, and that's in between 1 and 10, so that's where the decimal would need to go. So my answer would be 7.63 times 10, and how many other places I moved? I moved 4 places to the left. Remember, if I move, and you need to write this down, if I move to the left, that is positive places. If I move to the right with my decimal, that would be negative places. Since I moved to the left with a number that's above, that's not a decimal, you're going to be moving it to the left, it's going to be positive places. So it would be 7.63 times 10 to the fourth power. That number is the same thing as 76,300, because if I took 7.63 and multiplied it by 10 raised to the fourth power, it would give me this number right here back in my calculator, because they're the same number, just written a different way. Okay, our next number, 2,560,000. Again, it doesn't have a decimal, so I pretend like my decimal's at the end, and I have to move it over until I come to a number between 1 and 10. So I move it over 1, 2, 3, 4, 5, 6. So I get to, that will give me 2.5, which is between 1 and 10. So I'll write this out, 2.56. I moved 6 places to the left, so my exponent will be 2.56 times 10 to the 6th power. So that's how many places I moved to the left. Now, how about if we have a number that's a decimal, though? If we have a number that's a decimal, we're going to be moving that decimal to the right to put it in scientific notation. So if we look at 0.000066, I got to move my decimal to the right till I get to a number between 1 and 10. So I move it 1 place, 2, 3, 4, 5. Put my decimal, because 6.6 is in between 1 and 10. And that number becomes 6.6 times 10 to the negative 5, because I moved 5 places to the right. All right, now the last example, 0.005, I need to move my decimal to the right till I become a number between 1 and 10. So when I do that, I move it 1, 2, 3, and that'd be 5.0, or just 5, and that'd be between 1 and 10, and that becomes 5 times 10 to the negative third, because I moved 3 places to the right. So if I punched in my calculator again, 5 times 10 to the negative third, that would give me 0.005, because they are the same number, just written a different way. So it says to write number scientific notation. It's what I just went over. If the number's in decimal notation, move the decimal point to the right of its original position and place it after the first non-zero digit, which would give you a number between 1 and 10. The exponent of 10 will be the number of places the original decimal point was moved, and it will be negative since it was moved to the right. So Again, if we look at this example, got this number, I need to move my decimal to the right. It'd be 1, 2, 3, 4, 5. Because 6.43 is between 1 and 10, so I'll write that 6.43 times 10 to the, since I moved to the right, it would be negative 5. Would be the correct way to write that in scientific notation. Alright, another one, if the number to be changed in scientific notation is a whole number greater than 10, move the decimal point to the left of its original position and place it after the first digit. The exponent of 10 will be the number of places the original decimal point was moved, and we have positive since it was moved to the left. So again, if I have this example, I have my decimal would be at the end. Since I don't have one, I need to move to the left to get to a number between 1 and 10. So I move 1, 2, 3, 4, 5. I have to move that many places because 1.25 is between 1 and 10. And then that would be times 10 to the, move to the left 5 places, so it'd be positive 5. Like I said, if you punch in your calculator, this number 1.25 times 10 raised to the 5th, it would give you 125,000, because those are the same numbers. Same thing, just a different way of writing those. Now, every once in a while you might come across, if we look at these examples, I'm going to work one or two with you, and then I want you to work the rest of them, and then you can go over the answers once you're finished. But sometimes you'll have a number that's already in scientific notation, and there's a few of them here. Let's say we look at number 7. We have 281 times 10 to the second. Now this is in scientific notation, but it's not correct scientific notation. If I want to put it in correct scientific notation, I need a number between 1 and 10. So what I would do is kind of disregard the times 10 to the second for right now, and let's just put 281 in scientific notation. The decimal would be at the end. I would have to move it 2 places to the left, and that would end up being 2.81 times 10 to the positive 2, since I moved it 2 places to the left, but I also already have this times 10 to the second. Then what I'll do is just add my exponents. So it would end up being 2.81 times 10 to the 4th power would be the correct way to write that. Alright, now let's say we looked at one more like that. This bottom one, 3.67 times 10 to the negative third. It's not in correct scientific notation. I'm going to put it there. My decimal would be right there. I have to move it 2 places to the left to get a number between 1 and 10. So that becomes 3.67 times 10. And I moved it to the left, so that'd be the positive 2. But I still, a positive 2 since I moved it to the left. But I still have this negative 3 here that I would add to it. Positive 2 plus negative 3 would equal negative 1. So the correct way for that number written in correct scientific notation would be 3.67 times 10 to the negative 1st power. And that's how you would handle those. And that's all there is to scientific notation. So now work these example problems and then check your answers when you are finished.